So, let's do over here.
Yeah, where we?
Okay, so what are our two variables in this problem? This is problem 23 on page 451 of your GS71 book.
So you want me to just read it to you?
Sure.
Okay. According to the Bureau of Labor Statistics, for 2011, 48.5% of the civilian population 16 years or older was male, 34% was not in the labor force, and 70.1% was male or not in the labor force. So what we have to do is we have to find the probability of not being in the labor force, given that we know the person is a male.
So that's what we're finding. So how do we know what our two variables are in this problem?
Well, they kind of, already
Yeah.
laid it out for us. I would say because we're working with a labor force and they really only care about the males, they haven't mentioned like females. I'm gonna assume that we're probably gonna use, the labor force and the males. And there's like a lot of information in here, so maybe let's just try and pick out the stuff that they're giving us.
Mm-hmm.
So they're telling us 34%.
Hold on just a sec.
Yep.
Format this a little bit better. Okay,
Yeah, that's a
so
good
they're
idea.
telling us what?
34% was not in the labor force.
So, not labor force. If this was our labor force and this was our males, then the 34% is going to look like this. This would be what's shaded. Because not labor force, so you just avoid shading in the whole labor force circle.
Right.
So that's 34%.
Okay, yeah. They also tell us that 70.1% was either male or not in the labor force.
Okay, so that's a little bit weirder, right?
What kind of probability is that, Jensen? Is it and or is it or probability?
It's or.
Okay, cool.
Yeah, it's or probability. So then the issue with that is that you'll just shade all of the male, and then with or you just shade right on over. So then we say not labor force. We shade all of the not labor force. So we can notice here that the only difference between the two is that this bit here is shaded on the 70.1. So what we're going to do is we're going to say, we back up a little bit, 70.1, or I guess 0.701 minus 34. And that'll get us just this overlap, which we call labor force and male. Okay, so what did that come out to, guys?
0.361.
0.361. And so this 0.361 looks like this, right?
Right, yeah, it's just that piece that's both male and labor force. It's the intersection there.
Okay. Does someone else want to take it from here?
Yeah, I can take it. So we can go ahead and fill that in already. Do we have any other information, Judson?
We have 48.5% of the population was male.
Okay. So given that information, we can figure out the other part because they're telling us that that's all of this is equal to what, 0.485?
Yes.
So we already know what this is right here. We just calculated it 0.361. So we know that the rest, the portion, even though it looks a lot bigger, is going to be just that difference. So we do 0.485 minus 0.361, which gives us, what does that give us? Do you know?
0.124.
Alright, so that's going to be this other portion.
So we could call that 0.124, the percentage that is just male and not in the labor force, right?
Right. Mm-hmm.
Okay.
So at this point, are we ready to solve our problem?
I think we are, right? So we're trying to find probability that they're not in the labor force given that they're male.
Okay. So we have a total, how many are total males?
0.485.
Okay, right, so that's going to be on the bottom because they narrowed down our population to just those who are males. And now we're looking specifically at those who are not in the labor force, which is this 0.124%. So, what is this, 0.256?
Yes.
Awesome. So that would be our probability that they are not in the labor force, given that they're male. I think that's the whole question.
We can do 24 as well, right? Because 24 is based off of the same information. So problem 24 says, using the information from exercise 23 and the fact that 21.6% of the population is female and not in the labor force, find the probability of not being in the labor force given that the person is female.
Okay, so basically that 26 or 21.6% is just the not, right? It's just everything on the outside of those two circles.
So it'd be everything out here.
Yeah. Mm-hmm.
And was 21.6.
Yeah.
1.6.
Right, yeah. So you can go ahead and label that on our main diagram too. Alright, so let's look at what we're specifically trying to find. Maybe we're already ready. Find the probability of not being in the labor force given that the person is female.
So we still do have to find one more thing, right? Because this circle right here will be labor force, but not male. In other words, labor force and female.
So to find that one, it would just be 1 minus 0.361 plus 0.124 plus 0.216.
And we're doing that because basically we have everything filled in except for that. And this whole rectangle here is going to be 100%. So we're finding this last little bit to make up the 100%.
I think it's 0.299.
Yeah, I believe it was 0.299.
2.9.
Okay. So now, basically, it's still this, but just female, right? Or not male.
Yes. So in relation to that one, on the top we're looking for not in the labor force, given that they're female. So on top we'd have our not in labor force and female, which is 0.216. On the bottom we'd have our total females, which is 216 plus 0.299, and that comes out to
I believe it was 0.4 something.
That seems weird. Yeah, 0.515.
6 over 515,
That makes sense to me.
which is right around
Because it should just be
point
this minus 1.
4. No, not. Is it?
I'll do it on my calculator. 0.216 divided by 0.515 equals 0.419.
1.9.
Awesome. So what is that number?
This is the probability that they're not in the labor force, not given that they're female.
Perfect.
Or not male,
Yeah.
since these were the variables we were using.
Yeah.
Okay.
Well,